The previous classes we have seen how to iterate the elements of a map, how to iterate the keys, how to iterate the values, as well as how to iterate the entries of a map. Okay. Now in this class we'll discuss how to sort the elements of a map. Okay. There are different ways of sorting the elements of a map. The first thing is sorting using a tree map. Okay. If you want to go for a sorted map, then ideal way is to go for a tree map. But if you want to go for a sorted map, okay, what happens whenever we add elements? Let's consider like the map contains 100 entries. While adding each and every entry, okay, the existing entries will be compared with a new entry. Okay, which will decrease the performance like anything. Okay, let's consider like we have some 100 elements. Now how many times sorting occurs? 100 times sorting occurs. And how many times the elements will be compared means 100 into 100 times. So like that, to reduce that kind of things, we avoid tree maps. In general, we avoid tree maps. Okay, just because whenever we add new entry to the tree map, again the new entry will be compared with all the existing entries and sorting will be done for each and every element. So, which will degrade the performance like anything. So, to avoid that, in general, we avoid tree maps. But if we avoid tree maps, then how we can sort the elements? Okay? How we can sort the elements without a tree map? Okay? Means, let's see. Understood, right? The first and foremost thing how we can sort the elements of a map means using a tree map. Using a tree map, the elements are sorted based on the keys. But using a tree map is not advisable thing, just because whenever we add a new entry, okay, the sorting happens. So the new entry will be compared with all the existing entries, and all the existing entries will be sorted for each and every new entry, which will degrade the performance. Okay, so in general, to avoid that performance and memory leaks, we avoid using tree maps. But if we avoid using tree maps, how we can sort the elements? Okay, that's we will see. Okay, now let's have a linked hash map, okay, which has some keys. Now iteration is over. You understood iteration, right? Iteration using a map. Let me comment out these things. And just I have a map which is a linked hash map, and I have added some values. Okay, let's consider like it is 100. I have added some values. Okay, and let me sort the elements of the map. Okay, or the entries of the map. Let's sort the entries of the map. Okay, without using tree map. Okay, first what I'll do is I'll get the list. Now the intention of this application is to sort the entries based on the keys, without using tree map. So first what I do is I'll get a list of keys. The key set method, what it will do? It will return a set. Okay, key set method will return a set. I told in the very first classes that we can create any collection top up of any other collection. We can create a list on top of set, or set top up of list. Okay, now what happens is the key list contains all the elements that are present in the set. This will return a set. Am I right? So the array list, this key list contains all the elements that are present in the set. From where we are getting this set? Map dot key set. That means this list contains all the elements. This list contains all the elements that are exist as keys in that map. Now let me try to print this first. You can understand better. Semicolon inserted, where it is. Now it was compiled successful, and let me go to the classes. Let me use Java command. This connection. So now this collection will give a list of keys. A list of keys that are present in the map. Okay. Now key 24130. Okay. 24130. Now we have got a list of keys. So first what it will do? This will give a set of keys, and I am pushing the set of keys into a array list. So now this key list contains the list of keys. The list of keys present in the map. Understood? Now again I am getting list of values. Again I am getting list of value. Again I am creating an array list which is a sorted key list. Here I am creating an array list on top of the key list. So what I do is just step by step let me print the elements present in the corresponding things. First it is a key list, sorted key list, and value list. Understood now? Up to now, what we have done? We are creating a list of keys and list of values, and again we are creating a list of sorted keys on top of list of keys, and sorted key list contains the keys in sorted order. Okay, the keys in sorted order. Now what I am doing is, then after I am sorting the elements present in the sorted key list. Now is the size of the sorted key list and the key list same? Yes or will it be different? The key list size as well as sorted key list size will be different. Sorry, size will be the same. Now, are the elements of key list and sorted key list the same? Yes or different? Yes. But the sorting order is different. After sorting, what happens is the order will be different. Now, let me print up to this. Let me try to compile the application. It was compiled. Go to the classes. Execute the application. Now, if you see here, first this was the key list 24130. The second was the sorted key list. Now, in the sorted key list, what happens? The keys are in the ascending order of the keys. The keys are there in the ascending order in the sorted key list. Then these are the values. Okay. Now, what I do is, I'll go for loop. Just I'll clear the map. I'll put the key as let me put the value as null. Temporarily, it's not full-fledged. Just let me give the value as null. Now, the map contains the sorted key list as key and the value as null. Am I right? So, if you see here, required array required but the order of the large list found. Sorry, it's not like this. This is the syntax of array. Get off, right. Okay. This is earlier was the syntax of array, not a collection. Okay. This is a syntax of an indexed collection. Dot get off some value. Now, just did I print the map? Let me print the map. Okay, just I'm printing the map. Let's see how it will be. Now, how it is? Are the keys in the ascending order? Yes, but the corresponding values are there or not? Are the corresponding values are there? But the corresponding values are nulls. Then I'll go for the next step. I'll fetch the values for the corresponding keys. Okay. Now, how we can fetch the values for the corresponding keys? Now, first what I'll do is, then what it will give? What this will return? Let me write the example on the board so that you can understand better. First, what is the map? The map is key 2, key 4, key 1 and 3 0, key 3 and key 0. These are the keys and the corresponding values are 300, 400, 500, 600 and 800. Okay, this is the map that we have. First, what we are doing is we are fetching the key set. We are fetching the key set. Okay, and after fetching the key set, what we are doing is we are putting to another list, which is key list. Now, key list contains the keys in the insertion order: key 2, key 4, key 1, key 3, key 0. Okay. Now, the key list contains the keys in the insertion order. Okay. Again, I am fetching out the value list. Even the value list will be there in the insertion order: 300, 400, 500, 600, 800. Right? Now, what I am doing is, the next step what I am doing, I am getting a sorted key list on top of the key list. So, again I am getting a sorted key list. Sorted key list on top of the key list. So, we have key 2, key 4, key 1, key 3, key 0. Then after what I am doing, I am executing this collections.sort method on the sorted key list. So the keys will be sorted. So how the keys will be made to the sorted key list? After that, because of collections.sort, there will be 0, 1, 2, 3, 4. Alright? Now this is the sorted key list. Then what I am doing is I am iterating the sorted key list. If I iterate the sorted key list, what is the first element? Key 0. So then after what I am doing is I am clearing the map. So now the map doesn't contain any elements. Now the map doesn't contain any elements. So what I am doing is I am iterating this sorted key list. I am iterating the sorted key list, and first iteration it will fetch the first element. Okay? What is the first element in the sorted key list? Key 0. So I am putting key 0 as the key, and what I am doing is I am fetching the index of that element. Index of that element in the key list. Now, what is the element? Key 0. What is the index of this element in the key list? What is the index of this element in the key list? 4. Okay? The index is 4. Okay? Now what I do is value list dot get off that index. Then value list dot get off that index. Now what is the index that we get for key 0? 4. For key 0, the index in key list is 4. For that index, what is the value present in value list? 800. So again, I'll go from next iteration. Key 1 will go first one as a key. And what is the index of key 1 in this key, in this list? 2. So what is the corresponding value? 1. So key 3, 600. Key 4, 400. Sorry, key 2, 300. Key 4, first key 1, key 0, key 1, key 2, key 3, and key 4. And the corresponding values are 300, 400, 500, 600. First is P0 800 and P1 is 500 and P2 is 300 and P3 is 600 and P4 is 100. And this will be the lab which is sorted in the ascending order of the key. Understood? Understood everybody, or still do we explain more? First what you do is, we will get the key list, we will get the value list, okay? And then after we will sort the keys and values based on the requirement, and then we will declare the sorted list, and first we will fetch the element of the sorted list, okay? After fetching the element from the sorted list, based on whether we are sorting based on the key or value, we put the elements in the map. Understand? That's how we can sort the elements ideally with a map. Okay? This is a one-time job. Okay, but if you use a tree map, every time this process occurs, which is not advisable if we have more elements. Let's consider like there are 1000 elements in the map. It's not advisable to go for a tree map just because for 1000 times, 1000. Let's consider like we are in the 1000 iteration. The 1000 element will be compared with the remaining 999 elements, which is not the correct thing. Okay? But this sorting is a one-time job. This is preferable if there are more number of elements in the map. Okay? Just if you want, you can note down the example. Just don't note down the example. Just try to analyze and note down the example. Just I'll give a couple of minutes to note down the example. Just because it's a little bit tricky. Analyze the diagram on the board with the examples that we have. Which one? This one? The last one? This one? This one is the values, right? Yeah, it's sorted. It's not sorted. It's not sorted. By default, it is like that. 3, 4, 5, 6, 8. Just if you see the elements, the entries of the map, the values 3, 4, 5, 6, 8. It's the order that they exist in the map. But unexpectedly, it is sorted. It is not sorted to the map or the list. Just it is as per the order that exists in the map.
This one is getting value is sorted. So we have limits of there. After that sorted, we
first what we are doing? First come from here. Okay. First sorted key list dot get of 5. Okay. That means let's consider like first index. Okay. Get of 5. What is the value that is returned from the first index? Key 0. Then this will return key 0. Okay. And index of key 0. Key list dot index of key 0. What will give? Key list dot index of key 0 will give 4. Okay. Again, in the value list, we are getting the value at the index of 4. From the value list, we will get the value at the index of 4. Which is it? Okay. Over. Now, if you want to sort the elements based on the values, what we can do is, just let me execute this. So 0, 1, 2, 3, 4. The elements of the map are sorted in the ascending order of the keys. Now, if you want to sort the elements in the ascending order of the values, let me now these are the elements that doesn't exist in ascending order of the keys or even in the ascending order of the values. Now I want to sort the elements in the ascending order of the values. Okay? Then what happens is, then how we can do is, in case of sorted key list, we need to take sorted value list. Okay? In case of key list, we need to take value list. Okay? And while putting the values, we need to go for sorted value list. Okay? And now the second one is directly inserted. Sorted value list dot get out. Right. Now based on the value, we should retrieve the key from the key list. Okay? So what we do is, first what we do, from the value list dot index of sorted value list dot key 0. Again what we need to do, from the key list we need to get the value at that particular index, which is reverse to the previous thing. Understood this? This is a bit reverse to the previous thing. Previously, what we have done, just let me comment this. Let me put it in another page. Just let us try to compare the existing and with new values. Just let me comment this. Just try to compare the current with the existing. Then you can understand. Just for a minute, try to understand the commented for loop and the for loop we have in the application. This is for sorting the elements based on the values. Okay, and this is for sorting the elements based on the keys. Just try to compare, you can understand it better.
Functions that started value.
Okay, that's a mistake. Simple. It's sorted value list. Sorry. Understood what we have done? Everybody? How do I need to explain? No, not required? Or yes, it is required? Is it required? Just, it is the for loop that we have in the application is quite reverse when compared to the for loop that is there in the comments. Just what we are doing here is, we have a sorted key list and we are putting the map key as a sorted key list element, and from the sorted key list we are getting the index of the key list, and for that index we are getting the value. Okay, here we are doing reverse. First we are putting the value as the sorted value list element, and based on the sorted value list we are getting the index of the particular element in the value list, and based on that index we are getting the element from the key list. Just we are doing something reverse. So
there will be value list in line again.
Line? Sorry? It's value list. Even then it should not go. That was a simple mistake. Now, here if you see, the elements exist in the ascending order of the values, irrespective of whatever the key order it might be. Okay? So this is how the elements can be sorted. Elements of a map can be sorted based on tree or a value. Now if you go for a hash map, can we expect the order even after sorting? Can we expect the order after sorting if you go for a hash map? No. Even after sorting, we cannot expect the order of a hash map. So 500, 400, 100, 300, 200. It's not in the ascending order of values, or it's not even in the descending order of the values. So if you want to go for a sorted map, either we should go for a tree map, or if you want to do it through code, we should go for linked hash map. We should not go for hash map or hash table if we want to achieve sorting. Okay? Hash map or hash table will never give any order, will never guarantee any order. Okay? But linked hash map and tree map will guarantee some order. And this is how the elements can be sorted in a map. Okay. Now the next thing is sorting is over. Duplicate elimination, right? Duplicate elimination for this, and duplicate elimination for values is not a realistic scenario. Okay, eliminating duplicate values is not a very pretty much realistic scenario, but elimination of duplicates in the case of keys will be done by any map. If we provide the same key twice, what happens based on the equals and hash code method, it will evaluate the duplicates and the latest value will override with the existing value. Okay. But duplicate elimination for values is not even a realistic scenario. We need not to discuss about that. But duplication of keys or duplicate verification of keys will be done automatically in any map. If the same key exists twice means the latest value will exist. The previous value, the existing value will be detached. The existing object will be detached. Okay? And now let me have an address object. Now understood how we can sort the elements? Now since sorting is completed, let me comment out this code. Okay, and just let me do this. First, let me remove all the things. What I'm doing is I'm creating an address object and I'm putting the address object as a key. Value as some 100. Okay, now the map contains address object as a key and the value as 100. Now what I do is, after adding the key to the map, let me make null. Okay. Now, what could be the key of the map? Whether it will be null or whether it will be some address object. What could be the key of the map that is printed here? Will it be null or will it be some address object? Will it be null or will it be address object that exists as a key in the map? Just see here, I am making the address object reference ADD as null. Error. Why it is error? Just let me clarify him. Why do you think it is error? Just speak out. You have something in your mind, right? Why it is error? I can clarify. Why it is error or why it is not error?
Actually, I am the object. And actually, something is not into some class. Actually, to the
add is a reference, not object. Add is a reference to an object. Okay?
But we are assigning null.
Null. Can we assign null to ADD? Yes. Null can be assigned to any reference variable. It will not be compile time error. Null can be assigned to any reference variable, whether that reference variable is pointing an object or not.
But if it is before the assigning, then it is error.
Even before assigning, it's not error. Why it should be error even before assigning? Why this should be error?
No, sir.
Before?
And address add before null. And then we pass. And then again we pass R address, I is equal to new address, then what was it?
We are telling that this will be error. Are you telling this is error?
It is a null.
Why it is with null pointer exception? When null pointer exception occurs? If you are using a reference, if you are using a reference to access attribute or a method of an object, and if that reference value is null, then it is a null pointer exception. Now here, are we using the reference variable to access the attribute or method? No, it will not be a null pointer exception. Okay? First we told that it is error. Errors are different and exceptions are different. And then we told that it is null pointer exception. When null pointer exception occurs, if you are using a reference variable whose value is null to access attributes or methods of that object, of that class, then it will give a null pointer exception. This scenario, assignment will not give any null pointer exception. Okay? Now go for the previous thing. What could be the value? Will it be address object or will it be null? Just tell me one thing. What is the value printed here? Null. What is the value that we are adding to the map? What is the value that we are adding to the map? Null. Then if we are adding a value null to the map, then what happens? What happens in this case? What is the value present in the first system.out.println? What is the value that is printed in the first system.out.println? It is in 27 lines. Null. What is the value now? What is the key of the entry that is present in the map? Will it be null or will it be address object? Now the key of the map or key of the entry in the map, will it be a null value or will it be an address object? That's what my question is. Okay, let us see. Did I? No. I have missed something. I have missed the reference. What is the key? Is it null or is it address object? It's address object. Okay? Just because a map will have a soft references to the keys. Okay? Once a key is added, once a object is added to the key, see what happens? In a map, we have an entry, right? This is a map. We have an entry object. Okay? In the entry object, we have a key. We have a value. Key will be referring one object and value will be referring another object. Now, what we have done is, first what we have done, address object is being created. So, address object is being created with street name as Medipatham and door number as 1, 2, 3, 4. Okay? Now what it will do is, this address object is added as a key. This address object is added as a key. Now, this key will be pointing to the address object. Now, even ACD also will be pointing to the address object. Okay? Now, if this ADD value is changed to null, the ADD value is changed to null. Okay? Now, the ADD reference will be broken, but the key reference will still exist. Okay? Just because of this reason, Okay, the key still contains the object. Okay, and this reference is said to be a soft reference. The map keys will have soft references to the corresponding object. Keys in a map will have soft references to the corresponding objects. The keys in a map will have soft references to the corresponding objects. Okay, now let me go for some 10,000 iterations. Okay, even after 10,000 iterations, let me go for the map. Okay, even at the end of the iterations, even after executing 10,000 statements, still the key is address object and the value is 100. But let me go for a weak hash map. Okay, a weak hash map. Let me clear the screen. Let me compile the application, go to the classes and execute the application. What happens at the end of the iteration? Or not even it is going to the end. Even in the middle of the iteration, what happens? When it's not showing, let me go for simple 1000 iterations. Let me go for 1000 iterations so that it will be displayed on the screen. Now what happened in the middle? Why this has been deleted? Why this entry has been deleted from the map? Okay? This is the specific behavior of a weak hash map. A weak hash map contains weak references to its keys, or a weak hash map or the keys of the weak hash map contains weak references to the corresponding objects. The key of the weak hash map contains weak reference. The key of a weak hash map contains weak reference. Weak reference to the corresponding object. Now, in the same case, if it is a weak hash map, in the same case, if it is a weak hash map, this reference, let's select now it is a linked hash map. A linked hash map will contain, okay, a linked hash map will contain a strong reference, or even we can consider a soft reference. The linked hash map contains a soft reference to the corresponding object, or the key of the linked hash map contains a soft reference to the corresponding object. But if this is a weak hash map, the same is a weak hash map. what happens is, let's consider like this is a map, this is a entry, we have two attributes key, value, key will be pointing to another subject, where street name is Megapatam and 1, 2, 3. Now, the reference between the attribute key of the entry and the corresponding object is a weak reference in case of weak HashMap. Okay? But this reference is a soft reference in case of other maps. Okay? So, now whenever, why it is coming as an object for some iterations, but then after the element is deleted. Why it is being deleted? Means, whenever the element is garbage collected. Did you remember garbage collector? Did you remember the garbage collector? When the garbage collector will be invoked? At a specific time. It's not always in a regular manner. At some specific time, the garbage collector will be invoked as a multi-threaded manner. In a multi-threaded manner, the garbage collector will be invoked. Whenever the garbage collector is activated, at that time, if there are any detached objects, the objects will be removed from the queue. That's what the purpose of the garbage collector. Let's consider like we are executing some 1000 iterations. In the middle, garbage collector is coming in the picture. Then what the garbage collector will do? The garbage collector is supposed to remove this object from the queue. Just because it doesn't have any reference, doesn't have any external reference. But the garbage collector will verify whether the reference is a soft reference or a weak reference. If the reference is a weak reference, then the object will be garbage collector and it will be removed from the queue. If the reference is a soft reference, then it will still be there. It will not be garbage collector. The reference is a weak reference, then the garbage collector will remove an object from the heap, and what the WeakHashmap will do is, the WeakHashmap will remove the entry from the map. Understood? There are two things that are done. The first thing is, the WeakHashmap will remove the entry first. Then after, the object will be removed from the heap. This is the concept of WeakHashmap. Understood? Whenever the object is garbage collector, the corresponding, not the value, the key. The WeakHashmap makes a difference only with the key, not the value. When the value is garbage collected, it doesn't make any difference. But it makes a difference only with the key. When the key is garbage collected, okay, automatically the corresponding entry will be removed from the WeakHashmap, which will boost up the performance. Okay? Which will boost up the performance. Let's consider like we have 1000 elements. At a particular point of time, only 100 elements are not null values. The remaining 900 elements are nulls. Is it correct to persist all the 1000 entries? Is it correct? No. So only 100 entries should be there in the map. Just because the remaining 900 entries are nulls. So, in the performance perspective, in the perspective of performance, WeakHashmap will boost up the performance. But sometimes it will give unexpected results. It will lose the consistency. Let's consider like at one point of time I have executed the application. After one second, if I execute the same application and if the result set is different, it is inconsistent. The result set will be inconsistent, but the performance will be boosted up with WeakHashmap. Just because whenever the element is garbage collected, at that time itself, the entry will be removed from the map, which will boost up the performance, but the same thing will provide some inconsistent results sometimes. Will give some inconsistent results sometimes. If we compromise with that inconsistent results, we can go for a WeakHashmap for better maintenance. Just because whenever the key is nullified, automatically when a garbage collector is executed, the corresponding key will be, the corresponding entry will be automatically moved to the WeakHashmap, which will maintain the WeakHashmap in a perfect manner and
the performance will be boosted because of that. I've done an example, like we have at first we have added 1000 address objects to the map. But in the middle we have multiplied 900 address objects. But now only 100 address objects are values. But still the map size will be 1000 if you go for a WeakHashmap, which is not correct. It may not be correct in terms of performance. The object is nullified, there is no use of existing data entry in the map. But WeakHashmap what it will be removed, it will automatically remove that entry from the map. Whenever the garbage collector removes that object from the heap. Just because it holds a weak reference. Just because the reference between the key and the corresponding object of a WeakHashmap is a weak reference. Just because this is a weak reference, whenever the garbage collector comes in the picture and this object doesn't have any other reference, okay, then this object will be automatically removed from the WeakHashmap. The corresponding entry also will be removed from the WeakHashmap. Understood? Just some of the interviews will be asking. Okay, why WeakHashmap is required and why these advantages and what are the disadvantages of WeakHashmap? Okay? Understood? Can you tell? Can you tell to the interviewer what are the advantages of the WeakHashmap? Can you tell what are the disadvantages? The advantages are whenever the object is nullified, automatically the entry will be removed, which will boost up the performance. Disadvantage is inconsistent result between successful executions. Okay? And this will complete the basic collection concept. Okay? And the next thing that we are going to discuss is generics. But before discussing generics, we have a short break for 10 minutes. The class will be there up to 11 p.m. Okay? Let's have a short break for 10 minutes. And then after we'll start generics.
So in this case, the match between the value and that pointing is also key.
But this object will not be removed from the heap. The object will still exist from the heap. But in the next garbage collection, what happens? The value will not have any weak reference. The value will have strong reference. But what happens since the entry will be removed, the value object exists. But in the next situation, what happens? In the next garbage collection, the value, the object, 100, doesn't have any reference. So it will be garbage collection. Okay? Sir? Option is not closed. Break was option is changes. Atlas